Okay. Okay, so welcome back. Let's get started. Okay, so first thing is about the final project. Okay, so I already post all this like assignment thing on the module named as final project. Okay, so you can go look at them and check the details. And I also post the final project details on our course website. And you can find that there's a new tab on the sidebar, which is named as final project, okay? And it contains all the details, okay? So there are kind of like 1, 2, 3, 4, 5, like 5 major things for the final project, okay? So first thing is group formation, okay? And I already sent out the formation link, right? The Google Sheet. You guys get that, right? And you have to sign that up by next Wednesday, which is May 4th. And by that time, if you still haven't got a group, it's okay. I'm gonna just randomly assign you to one of the group, okay? And the next important thing is about the pitch. And your team, right after the team formation, you're gonna schedule a pitch presentation with me and both two tutors, and you can kind of just give us a brief presentation about what kind of thing you're gonna do, okay? What kind of idea you have, and how you plan to achieve that, and like what kind of technology, what kind of API you wanna call, maybe. So you don't have to be like very detailed, but at least give us some, the overview of your project or the app you want to do, okay? And this is quite important for us, to at least in the first place to see like whether the kind of the idea you are thinking about actually gonna work or not. Like whether we actually can fit your entire final project into maybe last 3 weeks of this quarter, okay? And the next thing is the final presentation, okay? So we will have the final presentation right here, which is gonna be scheduled in the last lecture this quarter on Thursday, I believe. Yeah, it's on Thursday, June 2nd, okay? And during that time, for your final presentation, first thing is, of course, you need to have a slides, okay? Kind of show some details, or like not details, but some like overall structure, like what's the goal of your app, right? And what kind of thing you want to achieve or you want to solve with your app. And another important thing for the final presentation is you're gonna present like how you actually interact with your app. It's kind of live demo of your product, okay? And during that time of like your presentation, you don't have to make sure like all like the app is bug free. It's okay if it contains some random crashes. It's okay, but just trying to avoid these crashes during the presentation, okay? Just pick the part which is good to go during the presentation, okay? And you're still gonna have like maybe 5 days, after the final presentation, okay? You can still keep working on the code base, and fix some bugs, polish on the code, and the final code submission is due on Tuesday, June 7th, and at the meantime, we're also gonna send out a group evaluation form right after the final presentation, okay? So you guys can kind of just grade your team members like performance and contribution, like whether your team member actually contribute like any significant thing to your like final project. If one of your team member, or hopefully we don't got multiple like people don't do anything, but if like one of your team member doesn't do anything, just be honest, okay? When you're filling out the group evaluation form, and well, we're gonna do some at least discuss about this thing, like if people don't do any work. Okay. Now you can go over all these details on your own, I believe. And one thing to mention is for the final project, you have to form a group of 3 to 4 people. It's kind of required, okay? And let me see, what else I miss? Okay. And after the next Wednesday, we're gonna actually create a group on Canvas for you. So you're gonna get some notification about, like, the group on Canvas. And all these assignments is gonna be created as a group assignment. Okay, so you guys just only need to submit one thing on the Canvas. And for the pitch, before the pitch presentation, you're gonna submit a slides. Okay, at least one day before your pitch presentation. Okay, and you can find the signing up sheet right here. Okay, so I believe it's Friday, week 5, 6, 7, week 7. Okay, and yeah, you're gonna sign up for that sheet, and we're gonna meet maybe via Zoom. I'm gonna send out the Zoom meeting link before like week 7 Friday. Okay, and also the pitch presentation is required. Okay, so you won't get any credits for the entire final project if you are not here. Okay, so it's required. You have to be here and to present, or at least be here. Your group is gonna present all these things, and you will have about like 10 to 15 minutes for your pitch presentation. And of course, you're in the slides, as I mentioned before, and there are several things you need to cover. Actually, let me zoom in this one. Okay, so there are several things you need to cover during the presentation, the pitch presentation. So first thing is the idea, like what kind of program you're gonna build and what kind of problem you're gonna solve with your app. Okay, and you're gonna like look into the app store, or the existing market, and see whether there's any counterpart, or the existing product to your kind of concept. Okay, and you're gonna see, like, you can tell us, like, what's the difference, what kind of change you want to make, or what kind of improvements you want to make upon all these existing products, and also what kind of essential functionality you want to include in your app. Okay, so what kind of workflow, or the interaction, how the interaction gonna look like, and how it actually like different from the existing products. Okay, and also you need to talk about the implementation. Again, it's just a pitch. You don't have to include all the detail about the implementation, because, well, to be honest, you won't know. Okay, and you just give us a brief timeline. Okay, like how you plan your work throughout the last 3 weeks this quarter. Okay, and you can start to give us about what kind of third-party libraries or web APIs you're gonna use. Okay, and well, all these things gonna change constantly. Okay, during your development, but it's okay. During the time of the pitch presentation, you can just give some like brief ideas about all these things. Okay, and about the final group project idea. Okay, you can have your own idea. Okay, that's why the pitch actually exists. Okay, because we want to examine your idea, like to see whether your idea actually gonna work, at least can be done in the like in 3 weeks. Okay, and also if you don't have any idea, or like if you are kind of new to the like app development, we have few kind of idea for you. So you can go all this list, and yeah, we also include some like potential possible API endpoint you can use in this idea. And yeah, the presentation, I think I cover all the detail. Yeah, you need to submit the slides at least one day before the final presentation. Okay, the portal is on the Canvas. Okay, and we haven't decided about how many time you're gonna have per group for the final presentation, because we haven't decided the group. Okay, once you guys finalize your group formation stuff, we're gonna send another announcement about all these details for the final presentation. Okay. And yeah, group evaluation. I'm gonna send another announcement about group evaluation right after the final presentation. Okay. And there's majorly there are 3 themes you're gonna submit. First is pitch slides, and second is final presentation slide. And the last one is final code submission. Again, your group need to submit 1 repository link of your final project on the canvas, okay? And that's it, actually. Now, let's actually get into today's topic. Okay, so today we're actually gonna cover some fundamental things about the SwiftUI. So far, what we have done so far is basically, okay, I do that thing. I use state, I use observed object, and it somehow worked, right? So today we're gonna talk about some fundamental details about SwiftUI, like how the life cycle of SwiftUI, how SwiftUI actually manage the lifetime of views, okay? So first, I'm gonna throw some concepts, okay? So which you're gonna constantly see these concepts in some documents or in some tutorials or in some articles. So the first concept, actually, there are majorly 3 questions, okay? These 3 questions is kind of formed by Apple during the WWDC. So when you're actually thinking about building an app, you're essentially thinking about 3 things. Like actually not building an app, building a view for your app. You're actually thinking about 3 things. So first thing is, what data does this view need, okay? So as you already, I believe you guys already know, like when you build a view, right? You have to use some data because you want to display something. That's why you need a view, right? And the next question is, how well you use that data, okay? So, user may change the data by, interact with the view, like clicking on the button or kind of stuff, okay? And how are you actually going to present this data? Because you may want to do some actual calculation on the data before you actually display this thing to users, okay? And the last one is, where does the data come from? That is actually quite important during the app development, because usually you may actually maintain multiple different data throughout the lifetime of your app, okay? And you have to be sure about like where the data actually come from, okay? For example, that data come from the database, okay? And you may have several copies during your runtime of your app, and you have to make sure that your data actually is reflecting, your view actually reflecting the data which is come from directly from the database instead of some temporary data which is stored during the some intermediate process. Okay, so there are 3 questions you have to think about. Now there's a concept of source of truth. So as a database I mentioned before, when you use the data, for example, when you use the data from a database, now the database becomes the source of truth, okay? So this is the concept of source of truth, just some fancy terminology here. But you're gonna see this term, like a lot of times if you go online, okay, and search the articles. Now, yeah, the source of truth is the source of data that you want to use, okay? And sometimes you may want to use some, just for some view, you may have some local state flag or variable. Let's take a look at this code. So last lecture, actually is last week, Thursday, we built a kind of action button here, okay? That code actually from there. And you can see there is one state variable named as show more, because when I click on the button, okay, kind of create a new fly out window, okay? And this is kind of temporary state variable which gonna be used to manage our view. And again, in this case, this is our source of truth, because it's just a temporary state variable which is managed in this view. Okay, when this view actually gonna disappear or kind of collect by the SwiftUI, this thing also goes away. Okay. Now let's talk about data ownership. Again, we take a look at this thing. Okay, so who actually owns the data? So in this case, as I mentioned before, this show more, this variable is a temporary state variable which is stored and managed by this view. Okay, so it comes with the lifetime of this view. Okay, so this view, this action button view, actually owns the data, owns the show more variable. Okay, so this is the ownership of this in this case. Okay, now take a look at this thing. So this time I'm going to use at binding. Okay, still remember the at binding thing, right? So by using at binding, essentially just create a binding, well, as the name says, create a binding from the parent view. Okay, so kind of create a reference to some variable in the parent view. In this case, this, for example, this action button flyout panel, this view doesn't own that data anymore. So that data actually owned by the parent view, which is action button. Okay, so you have to think about which view actually owns the data. Okay. Now, next concept is about lifetime, view lifetime. Okay. Now, take a look at this thing. For example, I have a view named as progress view. Okay, and it takes a argument which is a ratio, and of course the ratio is kind of a local variable stored in that view. Okay, and so when the view actually starts to appear on the screen, the lifetime of this view actually started. Okay, and during the beginning of the view's lifetime, there's one function that's going to be called, which is called onAppear. Okay, we're going to get to the onAppear later. Okay, and in the meantime, the SwiftUI also going to assign an ID for that view. Okay, and we also going to talk about the ID later when we get to the identity. Okay, but right now we create a view. Okay, create a progress view with a ratio as 0. Okay. Now, what if we maybe change the ratio when user maybe click on something or kind of behavior, some action happens. So, for example, I kind of increase the ratio. Okay, so right now SwiftUI actually reevaluate or create a new view based on the struct, which is the progress view. However, the lifetime actually for that one is kind of, the lifetime actually expanded. So you are still using the same view. Just the thing is the SwiftUI actually just reevaluate the struct, okay, and create a new view for the render or for the graphical layer to process, okay. But lifetime is still the same one, okay. Now, of course, you can again just change the state of that view and reevaluate. And right now, maybe the view gonna disappear, okay? And at that time, this one onDisappear gonna be called, okay? Now let's take a look at these two things. So first thing is onAppear, and the next one is onDisappear, okay? These two things actually are view modifiers, and the syntax is just exactly the same as other view modifiers, okay? It takes two closures, okay? And when, for example, in this case, when the progress view actually appears on the screen, this function block gonna be called, okay? So you're gonna print some string, say like view appeared, okay? And this is same case for the onDisappear, okay? Now, let's go back and take a look at this lifetime thing, okay? And you can see the view struct, in this case, is a progress view struct, okay? And the var body, still remember the var body, okay? So if you want to find some view, you have to have a var body, okay? Will be reevaluated many times during the lifetime of one view, okay? So the takeaway is you shouldn't do anything expensive inside the initializer of a view, okay? Because it's gonna be reevaluated again and again and again. And if you do something expensive, it can be a problem, okay? And actually, if you already know the else programming, you may know you can do some dispatch queue, to dispatch the, some work to the background, okay? But the thing is, actually, the Apple doesn't recommend to do all these things in the initializer, okay? So just keep all this expensive stuff away from the initializer, okay? So if you want to do something expensive, we're gonna talk about that later, which is the async await concurrency context, okay? And yeah, the view should be cheap, okay? Well, and usually we prefer a small view, okay? If you can make view more like modularized, a small, yeah. Sorry, what?
Is creating a state variable part of the initializer, or is kind of like outside
of the initializer? It's not, actually it's before the initializer. Okay. So for the internal implementation, it's before the initializer call. And so in this week's optional materials, you're gonna see there's an article talking about the full details of the life cycle of SwiftUI, and they're gonna include a little bit more details about like before the initial is gonna called. So the SwiftUI actually gonna manage something like add state and add state object. All these things we also gonna talk about. So for the add state object, we're gonna cover this later. Okay, and yeah, so SwiftUI gonna first manage all this add state, add observe object, add state object, all these things before the initializer actually get called. Okay, then go for initializer, and now you have a view ready. The unpaired gonna be called. Okay. Now let's take a look at the life cycle. So again, this is a screenshot from www.dc, and you can see the entire lifetime of the view essentially is a circle, right? And so from the source of truth, which is the data you're gonna use, okay? And you receive some update, okay? You're gonna update the view, okay? And the view receives some updates. The view gonna create a struct for the graphical layer to render the UI, okay? So so one thing is actually the view doesn't exist really long time when you're actually running your app. So all the view, just actually for us, like for programmer to see like how to construct a view, okay? During the actually runtime of the one app, the view gonna be created multiple times very frequently. And essentially all this view gonna be handed over to the render, or like handed over to the graphical layer. And they actually gonna decide how to lay out all these things. Okay, so this is actually two different processes. And when the UI actually receives some events, receives some updates, for example, maybe, guess we have a user action. For example, click on the button. Okay, that's an event. Okay, the event can sometimes mutate the data. Okay, when we mutate data, we're gonna reflect that kind of mutation. Okay, that kind of change on our source of truth, okay? And that's a kind of like a little bit more stuff. So as I mentioned before, so the event, anyway. So when the UI receives some events, right, you're gonna actually trying to mutate something, okay? So the events actually includes lots of things. For example, the user interaction, okay? And it can also be a timer, okay? It can also be some kind of notification, like Bluetooth state change, right? What kind of thing? And all this thing in this SwiftUI is called something as publisher. Okay, you already actually have been using publisher. Okay, so still remember the add publish thing, and like observed object, observable object. Okay, so when you're creating observable object, actually you're already embedded with a publisher. And when you change some data, for the data which is marked as add publish, you're actually gonna send something to the UI, right? See, I'm changed. I'm gonna let you to fetch some data from me, okay? And I'm gonna update the UI. So they're a publisher, okay? They're gonna publish their updates to the UI, okay? Now, let's take a look at all these tools the Swift or the SwiftUI actually provides to you. So first thing is add state, okay? You already see this thing and use this thing a lot of times so far, but there's a few things you have to keep in mind. First thing is the add state is owned by the view, okay? It's the ownership thing. So when you define the view, okay, the add state, you shouldn't have too many add state variable, okay? So all this add state is used just for some like temporary, like some state control, state management for a view, okay? For example, if you want to show a view, or if you want to expand the view, like what you have done in the assignment 2, okay? Expand the view or minimize the view. So that's kind of state you want to manage, and it's owned by view. So when that view goes out of scope or kind of disappear, okay, that add state variable get kind of collected by the SwiftUI, okay? And there's one more important thing is don't pass anything from the caller to a add state variable, and don't use add state on a reference type data, okay? Actually, we're gonna take a look at some concrete example, okay? So this is some code, okay? So on the left, we have a children view. Oh, sorry, actually, first take a look at the left, we have a children view, okay? So this is quite simple. We have add state, which is message, okay? The variable named as message, and we can display that, okay? That's quite simple. And on the right, we have a parent view. Again, in this case, we have a message marked as add state, okay? And I have a VStack with a button and a child view, okay? And when I click on the button, I want to change the message, okay? But the thing is, what I did here is I passed this message into the child view. However, take a look at this one. So what kind of the message in this child view? So it's an add state variable, right? You shouldn't do that. And actually, it's a kind of undefined behavior, because the add state should be managed and owned by the child view, okay? You should never do that, okay? Now let's take a look at like what do I mean by don't use add state on reference type data, okay? Now, first take a look at the on the right. We have a observable object, okay? And it's quite simple. You just have a variable named as num, and marked as add publish. And there's a function like add, okay? Essentially just add one onto the number, okay? Just kind of increment that number. And on the right side, I have another view, okay? And in this case, I say add state var view model and assign the demo view model, which is this one, okay, to this add state variable. And this is wrong. And in this case, maybe I want to use a button to click to kind of increment the number, and I want to display the number right here. But the thing is, you won't receive any updates. So the add state can only be used on value type data, okay? You won't receive any update on a reference type data, okay? Is that clear? Okay, all right. Now, let's talk about this thing, observed object, okay? So this observed object is not owned or managed by the current view, okay? And you have to manually manage its lifecycle, okay? So take a look at the code below. So when you have a observed object, you usually want to pass that observed object from the caller, okay? In this case, usually, I have an initializer, okay? And I take a reminder group view model, okay? This is the kind of the observed object. It kind of passed from the parent view, okay? Now, let's take a look at this thing, okay? This thing called @state object, and this is new, okay? @state object is kind of the combination of @state and @observed object, okay? And the usage, the syntax is kind of like that, okay? But the difference between the observed object is when you use the @state object, usually you want to initialize this thing right inside this view, okay? Instead of passing that kind of data from the caller, okay? That's kind of the use case of this thing. But actually, let's see why the @state object can be really important, okay? Why we need two different things, okay? Let's take a look at the code, okay? Again, have you guys fetched the latest data? So if you want to, latest code if you want to follow along. So we're gonna look at this one, the state object demo file, okay? Now, take a look at this thing, okay? Well, we already seen that in the slides, okay? And yeah, so this is another view, okay? Another view essentially just showing all these things, okay? I have a text, okay? And I internally managed a num in this view, okay? And I cannot increment the number, okay? By clicking on the button. Click on the button inside the parent view, okay? And I have another view, it's a child view, okay? And in the child view, I declare a local observed object, okay? And this one is the observable object I defined above. Is that clear? Okay, and in this child view, again, I have a text and I have a button, okay? And the text gonna display the number, okay, stored in this observed object. And the button gonna call the function to increment the number inside this observed object, okay? Now, actually, let's take a look at this thing. Let me run this. Okay, well, I forgot to switch back to the light mode. Okay, is that visible? Okay, so actually, just to mention, this one is actually wrong, okay? Just keep in mind, it's not right. So first take a look at the behavior. So when I click on the add in parent view, what's gonna happen? Come on. Okay, anyway, so you can just increment the number, okay? And what if I click on this thing, the add in child view, okay? Of course, you're gonna increase the number, okay? Like, it seems right, right? Nothing goes wrong. So, right now, what if I again click on this thing? Click this add in parent view button. See anything like wrong? So, what's wrong with this one? Because it kind of revert to 0, right? Okay, so the issue is, first take a look at the child view, okay? So for the child view, the number is managed by this observed object, okay? And when I click the button inside the parent view, okay, right here, this is a button, okay? Kind of increment the number which is managed inside this state object demo view, okay? And this variable is marked as @state, okay? So when it got some, when it gets changed, okay, kind of notify the UI, say, okay, I have some change, okay, and you need to redraw the view. Okay, so what happens when you kind of want to redraw the view? So you kind of go through all these things and redraw the child view. Okay, so what happens when you actually redraw the child view? So again, as I mentioned before, you kind of reevaluate the entire view. Okay, so when you reevaluate entire view, this thing gonna be assigned again, and this time, the view model create a new one. You get a new demo view model, right? And the number is 0. Okay, now, well, you can fix that with a state object. Okay, and the state object is alive and persistent across the lifetime of a view. Okay, so let's take a look at the demo. Again, I can click on this one, right, to add the number in the parent view. And I can click on this one to add number in the child view. So now let's go back to add another thing here. You can see this state actually persists. Okay, so the lifetime of this child view like exists all the time. Okay, and you don't want this one get like reevaluate, reinitialized multiple times. Okay, so that's why you use the add state object. Okay. Now let's go back to the slides. Is there any question on the code here?
So what is the difference between add state and add state object?
So the add state can only be used on the value type data. Remember?
Oh.
And in this case, we're gonna trying to observe on the reference type data. So that's why I say the add state object is kind of the combination of the add state and add observed object. You have some kind of similar functionality as add state, but meantime, you can use this thing on a reference type data. Yeah, it's object. Okay, now let's go back to this one. Now let's talk about environment object. Actually, it's kind of required in the assignment 2, but it just literally just one line of code. Okay, assignment 2, and usually you're gonna see it's kind of the abstract way of presenting all different layers of views. Okay, in your maybe some apps. Okay, so you may have a main view, and for the main view you may have lots of subview, and for subview you have lots of subview for the subviews. Okay, so all this structure gonna grow like really quickly, and the complexity gonna like increase, right? So now what if I have a add state object? Okay, it's maybe named as setting view model. Okay, inside the top of the main view. Okay, but what if I want to use this setting view model, this variable, inside of the subview? Okay, so it can be a tricky problem. Why is that? Because you have to change all the initializer of all the views. Okay, and you have changed the initializer of this view. Okay, you have changed the initializer of this view to accept the settings view model to pass from the parent view. Okay, you have to do lots of code changes, okay, in your code base, and that's a problem. So how are we supposed to fix that? With the environment object. Okay, you can call one view modifier named as dot environment object and pass in the object you want to share across all the subviews in this tree. For example, if I call the dot environment object on the main view, okay, by like passing the setting view model, right now, all the subview in their context, they already have the data, okay? But how are we supposed to use that? So we can, like for example, in this view, okay, in this view, we just declare a variable marked as @environment object, okay? You don't have to put the same name here, okay? You just have to make sure the type is correct. And the SwiftUI gonna actually figure out like what kind of data you want to fit into this context, okay? So you pass this settings VM, settings view model, right at the top of the main view, okay? And this thing actually already exists, all this in the context of all these subviews. And when you want to use that, just do this, okay? SwiftUI are gonna grab that data and put that into that view, okay? You don't have to modify anything in the, like, all the views between, okay? And this is actually kind of similar to the dependency injection, if you guys know what kind of thing that is, right? Okay, now let's get to the identity. Okay, so identity actually is quite important in SwiftUI because it can be used to optimize the performance of the UI redraw process, and actually can help SwiftUI to animate stuff. Okay, so let's take a look at like how does SwiftUI actually tell if two views are identical or not. Okay. So, well, of course, you use somehow like use some identity, okay, to identify the views. So there's two different types of identity. First is explicit identity. The second one is implicit identity, also called as structured identity. Okay. So for the explicit identity, you guys have been using that a lot of times so far. Okay. So for example, you have a score view. Okay. You use a for each to loop through some data. Okay. And take a look at this one. You remember, you have to specify some ID, right? Or you can conform that view to a identifiable protocol. Okay. By doing that, actually, you're gonna tell the SwiftUI, so the ID for each view. Okay. So by doing that, actually, it's similar to it's identical to do something like that. Okay, so we have another view modifier named as ID. Okay, you can manually assign an ID to a view. Okay, so when you do a for each with identifiable protocol or providing a key pass by like providing some data to the ID, you're essentially just doing something like that. Okay, explicitly assign an ID to each like child view. Okay, is that clear for the kind of syntax? Okay. Now, so what about like if views doesn't have explicit IDs? Okay, because you have been programming views, like you have been like doing lots of UI stuff, and usually you don't provide the ID for the view, right? You don't provide at least you don't explicitly provide the ID. Okay, so in this case, SwiftUI actually trying to like provide some default ID. Okay, for you, and every view in SwiftUI have an ID. Okay, take a look at this thing. So I have a VStack. Okay, let's assume we have a at top, which is a Boolean. Okay, and we can say if it's at top, I'm gonna put the image. Okay, with a spacer. Okay, if it's not, I'm gonna put a spacer first, and then it's image, and I have a button to toggle the at top variable. Okay. So what kind of behavior we have right now? Anybody? What kind of layout we achieved by doing this?
Vertical layout and the toggle button and face just.
Yeah, so essentially we just, when we toggle the button, we kind of move the image from top to bottom and from bottom to top, okay? So let's take a look at how SwiftUI actually see these things, okay? So the first thing SwiftUI see is a if-else statement, okay? And inside this if branch, okay, you kind of see some view, okay? And it assigns some random ID to that view, okay? And for the else branch, again, Swift is gonna say like, oh, it's a new view, okay? I'm gonna again assign some random ID which is different from the previous one to that view. So SwiftUI think like you got two different views, okay? Now, what's the problem here? So you should think about like, are these two views actually gonna be the same view, exactly the same view, okay? Just with some different layout, okay? In this case, actually, for the purpose, they are actually should be the same view, okay? We simply just move that image from top to bottom, okay? So this is kind of the wrong way to do that, okay? So let's say, what if you want to apply some animation, okay, to move the image from the top to the bottom or to the from the bottom to the top. You want to apply some animation. You can try that, you know, after class. Actually, I don't think it's gonna happen, or it's gonna be lots of trouble to do that. Okay. So actually, let's take a look at the demo. We got 2 minutes, so we're gonna take a look at this structure identity file. Okay. And so this thing, okay, this view is the view actually is the code I just showed you guys. So it's a kind of the wrong version, okay. And let's take a look at this thing, okay. So, well, that's a behavior you want to achieve, okay? So you actually, when you're trying to apply some animation to that, you will get some trouble, okay? You can try that, you know, after this class. But let me show you actually the right way to do that, okay? Take a look at this thing. Let me first pause this thing. Take a look at this thing, okay? In this case, we just have a VStack here because I want to, you know, put an image here and put a button here, okay? But in this case, I don't use the if-else because essentially they're just same view. If I use if-else, the SwiftUI are going to think like you have 2 different views, okay? But in this case, I have an image, okay, which is the smiley face, and I apply a frame to maximize the frame vertically, okay? And I'm going to just change the alignment using the view modifier, okay? And I'm going to apply animation to that, which is the default animation, okay? Now, I'm simply going to change the at top. So right now, based on the structure, we are going to say, okay, so this one is the view, right? And during the lifetime of this view, it has exactly the same identity, and this is the same view, okay? So we're going to actually animate this thing. So let's take a look at the demo here. I'm trying to run this one. And I can click on the toggle, and you can see you can apply animation easily, okay? So whenever you find some, you know, you think you get some trouble trying to animate some views, you have to think about first, like, well, actually, I'm doing the right thing, because, well, actually, the 2 view I want to animate should be the same view, okay? That's the one major thing we should consider. Okay, any question on that? Yep.
So when we create view using for each, why the SwiftUI doesn't just assign random ID to it? We have like why we have to provide our own ID?
The major thing here is about the, actually I should cover that thing, but we don't have time. So let me see. Okay, so for the identity, we have 2 like concept of identity. First is stable identity, and second one is unstable identity. And when using for each, when the SwiftUI somehow, you know, just randomly assign some ID to the view, actually it's an unstable identity. And usually it's not desirable. Okay, but we're gonna talk about that next week. And next week we're gonna also go over the, let me see, the high order function and optional and error handling. Okay, sounds good. Yeah, that's all for today. Thank you guys.